A straight ceramic rod looks simple until load enters it. Keep the material the same and change only the diameter, and the way that rod resists bending changes dramatically. Strength, toughness, surface quality, support span, and cross-section all meet in one continuous load path. The engineering term here is Yttria stabilized zirconia ceramic rod. In this straight round form it can remain a structural rod, or become a precision blank for a shaft, guide pin, or plunger after grinding and finishing. The final name should follow the geometry and function actually machined into the rod. For this rod family, the reference values include density at or above 6.0 grams per cubic centimeter, flexural strength at or above 900 megapascals, Vickers hardness around 12 to 13 gigapascals, and fracture toughness around 8 to 10 megapascal square root meters. These are material level references, not automatic ratings for every finished geometry. In transformation toughened Y-TZP grades, stress concentrated near a crack tip can trigger a tetragonal to monoclinic phase change. The associated local volume expansion acts against crack opening and raises resistance to crack propagation. The magnitude of that effect depends on Yttria content, grain size, processing history, and service environment. Dense zirconia can be ground to a hard, smooth surface, which is one reason it appears in sliding and pump components. Its thermal conductivity is low for an engineering ceramic, and it is electrically insulating. Chemical compatibility, hydrothermal aging, temperature, and surface finish still need to be reviewed for the actual operating medium. For a solid circular rod, the second moment of area is pi d to the fourth divided by 64. Flexural rigidity is E times I. For the same material, that means diameter enters bending stiffness to the fourth power, so a modest change in diameter produces a much larger change in resistance to bending. Increase the diameter by only 10% and the section moment of inertia rises by about 46%, because 1.1 to the fourth power is about 1.46. Quick check. For a solid round rod, which power of diameter controls this geometric stiffness term d to the fourth or d squared? Geometry does not remove ceramic fracture mechanics. Under bending, the outer surface carries the highest tensile stress, so scratches, edge damage, local point loading, and misalignment can become critical. Support span also matters strongly. A long slender rod therefore needs different guidance and mounting logic from a short, thick one. Within this rod series, diameter ranges from 0.2 millimeters to 40 millimeters. Maximum length increases with section size. Sub-millimeter rods extend to about 100 millimeters, 1 to 2.5 millimeter rods to 300 millimeters, 3 to 10 millimeter rods to 500 millimeters, and larger 11 to 40 millimeter rods to 600 millimeters. Commercial zirconia rods appear in both metric and inch size systems, but there is no single universal rod size series for every application. A custom requirement may involve diameter, overall length, straightness, surface roughness, and faces, chamfers, steps, holes, or threads after machining. The mating fit and support method should be defined at the same time. One representative application is a precision pump plunger or shaft made from a finished zirconia rod blank. 4 characteristics become relevant in that role: a wear-resistant sliding surface, corrosion-stable fluid contact, toughened crack resistance, and precision ground geometry. In a reciprocating pump, the plunger or shaft moves through a matched guide, sleeve, or seal interface. Diameter control and straightness affect alignment. Surface finish influences friction, wear, and sealing behavior. Zirconia brings a hard, polishable surface and comparatively high ceramic toughness, but the actual medium, temperature, pressure, lubrication, and aging environment still govern material suitability. A zirconia rod does not become a reliable moving component by material name alone. Its diameter sets flexural rigidity, its surface carries the sliding interface, and its support determines how load enters the ceramic. Precisely machined Yttria stabilized zirconia rods work when material grade, geometry, finish, and operating environment are engineered as one continuous load path.